Hey everyone, how you guys doing today? This is the last video of this saga. It's funny because at the point of this recording, none of these videos have actually gone up onto my channel. Um, and I'm still not sure what this will be called. I want to call it like there's a couple of different things with the core theme being that I am pretending to be a beginner. I guess that could be the name, pretending to be a beginner. Um, yeah, something like that. Um, yeah, something like that. I don't know, whatever this saga is called. Either way, this is the last video. We went through chapter 17 yesterday. Chapter 18 and 19 are both what I'm going to do today. I don't think there's going to be much in 19 that is of value that it will require a separate video. Just preemptively, I don't think I've even looked at. Actually, let me just look at it. Oh, it's literally just an outro. Um, hmm. For more about Python and good advice how to use it, I'd recommend Fluent Python, clear, concise, and effective programming. Um, Fluent Python. So yeah, as I expected, chapter 19 doesn't have much of anything, honestly. It's just like recommendations on next steps and things like that. You might find it helpful to review the sections of the book about debugging in particular. Book suggests tools to help with debugging, print, blah, 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 blah. It also suggests tools for testing programs, including but the kind of debugging is the kind you don't have to do if you use internal development. Throughout this book, I've suggested ways to use virtual assistants to help you learn. Yeah, there's literally nothing in this chapter, so I'm not even gonna look at it. What is this? Well, the whole book is available? What the hell is this website? Elmukri.com? Translate to English? um, Under construction, but you can go. My name is Mulay El Hassan Al Morki, and I'm an industrial Discard my profile and contact me below. About me, I was at their house. I'm assuming these are the places I worked at. Fantasies. Fantasies? I don't know what that means. Uh, Leave a comment. Space exploration. Okay, so I do not understand how on his website I have a full copy of this book. It actually looks like a good book. There you go. That's what I was looking for. fpy.li/code. Okay, this is literally just the code. Mm, I'm getting mildly distracted here. This is a large fucking book. Oh, Jesus. Class metaprogramming. Yeah, I'm gonna save this book for myself. Just gonna save it as a tab group and keep it Googled separately in case someone discovers and takes it down off of Mr. El Murki's website. New tab group, Fluent Python. I'm gonna remember this because this book actually looks good for me. Chapter 18. Okay, so we determined there's nothing much in chapter 19, and I got very distracted by chapter 18. I got super silent because I was just like reading it and checking out the table of contents, and I'm like, wow, this is a good book, or looks like a good book. Anyways, it's getting into it. Let's wrap this up. Here are versions of the card deck and hand classes from chapter 17 we will use in some examples in this chapter. So class, deck, card deck in hand, no problem. Python extras. One of my goals for this book has been to teach you as little Python as possible. When there were two ways to do something, I picked one and avoided mentioning the others. Or sometimes I put the second one into an exercise. Now I want to go back for some of the good bits that got left behind. Python provides a number of features that are not really necessary. You can write good code without them, but with them you can write code that's more concise, readable, or efficient, and sometimes all three. Sets. So sets are like lists, except every item is unique. Python provides a class called set that represents a collection of unique elements. To create an empty set, we can use the set object. Boom. We can use the add method to add elements, A, B, or we can pass any kind of sequence to set, and it will be turned into a set. An element can only appear once in a set, or if you create a set with a sequence that contains duplicates, the result contains only unique elements. Some of the exercises in this book can be done concisely and efficiently with sets. For example, here's a solution to an exercise in chapter 11 that uses a dictionary to check whether there are any duplicate elements in a sequence. This version adds the element of t as keys in a dictionary and then checks whether there are fewer keys than elements. Using sets, we can write the same function like this, len s less than len t, and be done with it. An element can only appear in a set once, so if an element t appears more than once, the set will be smaller than t. Set objects provide methods that perform set operation. For example, union computes the union of two sets, which is a new set that contains all elements that appear in either set. Some arithmetic operators also work with sets. For example, the hyphen operator, which performs subtraction, performs set subtraction. The result is a new set that contains all elements from the first set that are not in the second set. Chapter 12, we used dictionaries to find words that appear in a document but not in a word list. We use the following functions, which takes two dictionaries and returns a new dictionary that contains only the keys from the first that don't appear in the second. With sets, we don't have to write the functions ourselves. If word counter is a dictionary that contains the unique words in the document and word list is a list of valid words, we can compute the set of differences like this. Boom and boom. Um, Result set that contains the words in the document that don't appear in the word list. The relational operators works with the set, for example, less than equal to checks whether one set is a subset of another, including the possibility that they are equal. Okay, that one I did not know. With these operators, we can use sets to do some of the exercises in chapter 7. For example, here's a version of uses only that uses a loop. Uses only. Okay. Uses only checks whether all letters in a word are in available. With sets, we can rewrite it like this. Sure. Okay, so sets are great. Counters. Counter is like a set, except that if an element appears more than once, counter keeps track of how many times it appears. Yeah, I've never actually used counter before, so B1, A3. So counter essentially creates a dict from the sequence with the counts. From collections, import counter. Counter object is like a dictionary that maps from each key to the number of times it appears. We can use counter objects to solve one of the exercises from chapter 10, the anagram one, supposedly, counter.mostCommon. Oh, so counter provides a method called the most common that returns a list of value frequency pairs sorted from most common to least. They also provide methods and operators to perform set-like operations, including addition, subtraction, union, and intersection. For example, the plus operator combines two counter objects and creates a new counter object. Default dict. The collections module provides default dict, which is like a dictionary, except that if you access a key that doesn't exist, it generates a new value automatically. I believe they mentioned this as well, or mentioned it in one of the Ask a Virtual Assistant ones, and I remember looking it up. You provide a function that's used to create a new values. A function that creates objects is sometimes called a factory. When you create a default dict, you provide a function that's used to create new values. A function that create objects is sometimes called a factory. The built-in functions that create lists, sets, and other types can be used as factories. For example, here's the default dict that creates a new list when needed. So notice that that the argument is list, which is a class object, not list, the function, which is a function called that creates a new list. The factory function doesn't get called unless you access a key that doesn't exist. So T equals D new key. T is an empty list. The new list, which we're calling T, is also added to the dictionary. So if we modify T, the change appears in D. T.append, new value. D new key is new value. It's pretty neat. If you are making a dictionary of lists, you can often write simpler code using default dict. If you're making a dictionary, you can, in one of the exercises in chapter 11, I made a dictionary that maps from a sorted string of letters to a list of words that can be spelled with those letters. Here's the original code, and here's a simpler version using default dict. Boom, default dict is great. Conditional expressions. Conditional statements are often used to choose one of two values like so. This statement checks whether x is positive, so it computes the algorithm, if not math or log. To avoid stopping the program, we generate a nan, which is a special floating point value that represents, not a number. We can write the statement more concisely using a conditional expression. So yeah, I've seen these before where essentially you can do like an if-else in one line. You can almost read this line in English: y gets log x if x is greater than 0, otherwise it gets nan. Recursive functions can sometimes be written concisely using conditional expressions. For example, here's a version of factorial with the conditional expression. Boom. Another use of conditional expressions is handling optional arguments. For example, here is class definition with an init method that uses a conditional statement to check parameters with a default value. If contents is none, contents equals empty list. Contents equals empty list if contents is none, else contents. Yeah, so very, very nice. List comprehensions. These are my bread and butter. I love these. I almost love turning anything humanly possible into list comprehension because I love them. And it's exactly what it sounds like. It's like within a list, you can write a for loop because a lot of for loops are about generating lists. And so they just decided that you can just do that inside a list. Bracket operators indicate that we're constructing a new list. The expression inside the bracket specifies the elements of the list, and the for clause indicates what sequence we are looping through. The syntax of a list comprehension might seem strange because the loop variable word in this example appears in the expression before we get to its definition, but you get used to it. Yeah, that is true. So word for word in title.split compared to like if you wrote this as a regular loop where you write the for loop first and then you do the thing. So yeah, it's pretty common to use, or at least in the DS world it is. They're super useful. You can do almost everything, and they're awesome. So definitely getting in line with list comprehensions. I love that stuff. When a list comprehension is used as an argument to a function, we can often omit the brackets. For example, suppose we want to add up half n for blah 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 blah. We can use a list comprehension like this, or we can leave out the brackets like this. In this example, the argument is technically a generator expression. If they didn't say it, I was about to say it. Not a list comprehension, and it never actually makes a list. But other than that, the behavior is the same. List comprehension and generator expressions are concise and easy to read, at least for simple expressions, and they're usually faster than equivalent for loops, sometimes much faster. But in my defense, list comprehensions are harder to debug because you can't put a print statement inside the loop. I suggest you use them only if the computation is simple enough that you are likely to get it right in the first time, or consider writing and debugging a for loop and then converting it to a list comprehension. Yeah. So these are I like that he pointed out the difference between pointed out that this line, when you omit the square brackets, is actually a generator expression, but he's not explained what that is. And essentially, and this might be difficult to understand, but it's a lazy iterator. Okay, meaning instead of like in a list comprehension, it will create a list that you can index at any time or anything like that. A generator expression actually is a generator, is not actually a collection of any kind or a data structure of any kind. It's just an object, and that object essentially has the rules to create each element, right? It has some rule and it knows the rules, but it's not going to do it till someone asks it to do it, right? So here, this list comprehension that we passed to sum, right? That essentially creates the list first and then passes it to sum. Here, what it's saying is like, hey, sum, you take this, and then whenever sum needs to use that iterable, right, it will just evaluate this expression at that point in time, right? Rather than doing it before it's actually needed, because it's somewhere inside the code for the function sum that it's needed, not before the code is actually, not before the function is actually called. Okay, list comprehensions and generator expressions are concise and easy to read, at least for simple expressions. They're usually faster than the equivalent for loops, sometimes much. Okay, we already talked about this. Any and all, it's pretty simple. Any takes any iterable, and remember the difference between iterables and sequences. It's kind of the difference between a generator and a list. A list is a sequence. An iterable is all sequences are iterables, but not all iterables are sequences. And the key difference is being basically a sequence is a complete collection of elements which can be indexed at any point in time, right? You can index any value. Whereas a generator expression, you can't index it, right? Until it's completely done iterating through the entire thing. And even then, actually with generator expressions, once each element is yielded, it's forgotten. It doesn't exist, right? So any and all are very simple. You give it any iterable, and if any element in that iterable can be evaluated as true, then any will return true. And Uh, Otherwise, if all of them are false, it'll be false. Or with all, you can do the same thing, but if all of them are true, then it returns true, right? And it's not literally just a Boolean, like we spoke about this earlier, where there in Python there's truthisms, right? Truthiness. Like for example, the number 0 is evaluated as false, whereas any positive number is evaluated as true. Empty lists are evaluated as false, versus lists that have things in them, which is evaluated as true, etc., etc. That example isn't very useful because it does the same thing as the in operator, but we could use any to write a concise solutions to some of the exercises. Yeah, okay, I'm not going to get into all the places you can use it, but any and all are very useful. Named tuples. From collection, import named tuple. There's a lot of code to convey a small amount of information. Named tuple provides a more concise way to define classes like this. First argument is the name of the class you want to create. The second is the list of of the attributes point objects should have. The result is a class object, in which is why it is assigned to capitalized version of the name. Huh? I'm confused. Okay. Name of the class you want to create. The second is a list of the attributes point object should have. The result is a class object, which is why it is assigned to a capitalized variable name. A class created with named tuple provides an underInt method that assigns values to the attributes, and it understood this. Okay, so named tuple actually creates a class. It actually literally creates a class. Okay, I did not know that. I thought it was a specific data type. Cool. And honestly, all types are classes technically. So, fun. Point also provides an EQ method that checks whether two point objects are equivalent, that is, whether their attributes are the same. So basically, a lot of the boilerplate you would have to do to write a provides a quick way to define the drawbacks that simple classes don't always stay simple. You might decide later that you want to add methods to a named tuple. In that case, you can define a new class that inherits from the named tuple. Or at that point, you could switch to a conventional class definition. Yeah. So this basically takes out a lot of the boilerplate if you're making a super simple like data holder class, for which honestly you should use something like data classes or a Pydantic. So the name tuple gives you the EQ method, the init, the stir method, and I think it also does LT, because I did. Okay, no, it doesn't. I don't think it does. Never mind. Packing keywords are keyword arguments. In chapter 11, we wrote a function that packs its arguments into a tuple. Def means star args. You call this function with any number of arguments, but star operator doesn't pack keyword arguments. So calling a function with a keyword argument can cause an error. To pack keyword arguments, star operator, yes, star quargs. And it's the star and the star key are so annoying because they actually do the opposite in opposite inside of like the code. So star args, if you just accessed args, it's just a tuple, right? And star quargs is and quargs is just a dict. So to unpack those, something about star and star. I remember star and star outside of function definitions. Python. I remember this. Operators have specific meanings when used outside of function definitions. For unpacking iterable. Okay, it is still unpacking. Yeah, so it's weird because inside of a function definition, it packs things together. So star args will take multiple positional arguments and pack it into a tuple, or quargs into a dictionary. But outside of that, it actually does the opposite and it unpacks it, right? It takes whatever you give it and unpacks it and opens it up, right? So it's a little confusing and weird. At least that's how I felt about it. Um, but very, very, very handy, very, very important. So a little run through on star args and star chart quargs. Oh, debugging. We're at the end here almost. Anyway, in previous chapters we used doc test to test functions. For example, here's a function, blah blah blah. Function takes a function object and runs its doc test. So we can add like this. There's no output, which means all tests pass. Python provides another tool for running automated tests called unit test. It is a little more complicated to use, but here's an example. Def test add result add to self dot assert equal result 4. First, we import test case, which is a class in the unit test module. To use it, we have to define a new class that inherits from test case and provides at least one test method. The name of the test method must begin with test and should indicate which function it tests. Okay. Import the test case. The name of the test method must begin with test and should indicate which function it tests. Okay. Example test add tests the add function by calling it, saving the result. I don't think that's what it specifically needs to be named, but that is good convention to test add. In this example, test add tests the add function, saving the result and invoking assert equal, which is inherited from test case. Assert equal takes two arguments and checks whether they're equal. In order to run this test method, we have to run a function in unit test called main and provide several keyword arguments. The following functions show the details. If you're curious, you can ask a virtual assistant explain how it works. Run unit test, exit false. I'm assuming that if a unit test fails and exit is set to true, it's just going to exit out of the program. Verbosity is like how verbose the output is. Run unit tests, exercises. Yeah, this was kind of like a nothing burger thing. I'm not even going to go through all of these. I'm not even going to try to skim it like I normally do. So yeah, I think overall this was a good book, and for beginners and for people starting off, like it really does take its sweet time building things up. And honestly, for someone who has some generalized exposure to programming, this book is a bit too early. But for people who are it's a bit too early, but for people who are like right at the beginning of their journey of learning, not Python, but learning CS in general, right? And learning programming. Because if you're just learning Python and you're just exposed in general, maybe just go to the Python tutorial, the official one, or maybe read that I don't think even that Fluent Python book would be as good as Python tutorial in that case. I think that's the appropriate thing to do if you are beginning, is to do this book and go through the exercises and stuff. And clearly it's very accessible, so that's a great thing. I saw the other day that there's videos for it as well. Just Google this because I remember seeing this. You all get an idea of my books for data science developing Python skills shorts. Okay, that's weird. Yeah, see, this is the one, Alan Downey. He's the person who wrote this book. Okay, this is very weird. Bite-sized Bays. Think Python Chapter 1, Part 1, This is so confusing. I don't understand. Like, he started it and then he abandoned it around Chapter 3. I don't know why. The Jupyter notebooks are freely available online and they have essentially the whole book. Um, Here it's like, I don't know what this is about. Anyways, point is the book is super accessible. All the code is available. It's all put together as a Colab notebook, which means it's free for anyone to try and play around with. Like literally, if you have access to a computing device and the internet, you can access this book and start learning if you want. Technically, you could even do it on your phone, I think. I'm not 100% sure about the phone thing. Though it just becomes really hard to code on a phone compared to something with a keyboard. You could connect like a keyboard to your phone if you're super crazy like that. That's not necessarily a bad idea. It's just like what you can just plaster the phone right to your face or something like that. I mean, you could get one of those neck holder thingies so that the phone is right in your face as you're typing on the keyboard and the keyboard is connected to that. I think that would work, but then there'd probably be other limitations of cookies or something. Actually, I don't know. And you know what? Let's confirm this. Let's try and go to Google Colab on my phone and see how that goes. See if I can. Actually, I'm just gonna search. Wait, this chapter. Okay, let me open it in Safari. Let's say I hit. Okay, I'm gonna scroll to the top. Run anyway. So it looks horrible, and it is kind of janky in terms of moving it around and stuff, but it does work. Yeah, because like the difference, scrolling is very weird because yeah, it's janky, but you can technically do it if you want to. So it's a bit difficult on your phone. That's like a bit of a stretch, but it is still technically doable. So yeah, I highly recommend this book. You know, and if you decide to power through this book, hit me up. I'm looking to mentor people / take on interns to try and help me actually move forward in this project at a better pace. Um, yeah, that's actually a big deal. I am looking for people to work with. So if you are out there and you are interested, um, feel free to reach out to me. I don't know how that would happen because I don't think my email or anything like that is displayed on my channel. So I should probably fix that at some point. Anyways, thank you so much, everyone. Have a good one and take care. Bye-bye.